Welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 5 from the October 2024 Pure Mathematics P4 International A-Level Edexcel exam. And this question here, we have about related rates of change. So they're given us a figure which shows a container in the shape of a hollow, inverted, right, circular cone. Okay, so it's hollow, means it's not solid, empty. Inverted, upside down. Okay, cone this way is the right way up. Okay, and this way is inverted, upside down. Okay, right circular cone. Okay, right means the vertex. Okay, if you draw a line down, it's perpendicular to the base. All right, so it says the height of the container is 30 centimeters and the radius is 12 centimeters, as shown in figure 3. So that's the container. Now what's happening is the container is initially empty when the water starts flowing into it. So it's got no water in it, and the water flows into it. Okay, when the height of the water is h centimeters, the surface of the water has a radius r centimeters, and the volume of the water is v centimeters cubed. So this is like the water going into the container, and when the height is h, the radius is r centimeters, and the volume of water is v centimeters cubed. So the v stands for the volume of the water as it fills up the container. So we've got to show that v is equal to 4 pi h cubed over 75. That's what we've got to show. All right, so we got the diagram here, so that's all we really need. So we need to find the volume of water in terms of just h, no r. We know that the volume of a cone is given by 1/3 pi r squared h, as they told us. So what we need to do is we need to basically take this r and express it in terms of h, because we want to have this as our formula. There's no r in there. So how do we eliminate the r from this formula? Well, what we can do is we can think about the shape of this water and the shape of this cone. They're basically similar figures. You can make like a triangle. Okay, you can make like a triangle. That's like the whole cone. It's like you're taking a slice out of the whole cone. Okay, and you can take a slice out of the water. You can think about the water shape. These two are similar triangles. Okay, one of the triangles will look like this. Okay, and the other one will look the same, but it'll be smaller. Okay, just so all right, I'm just messing about here. Okay, so now I have these two similar shapes. So the small one represents the water, okay, and the big one represents the cone. All right, so now what do we have here? This is the height of the container, which is 30 centimeters. Which is 30 centimeters. This is the radius of the container, which is 12 centimeters. This is the height of the water, which is h centimeters, and this is the radius of the water, which is r centimeters. So because they are similar shapes, the ratio of their corresponding sides is the same. So if I want to have r in terms of h, I can say the ratio of r to the two radiuses, r to 12, is equal to the ratio of the two heights, which is h over 30. So I can say that r is equal to 12 times h over 30, which if you divide by 6, I guess, you'll get 2h over 5. So I know that r is the same as 2h over 5. So the volume of the cylinder, the cone, is 1/3 times pi. So we've got the volume of the water now, the volume of the water, which is defined as V anyway, so I'll just put V, is 1/3 times pi times r squared, which is 2h over 5 squared times h. And that should give us the correct answer. So you got a third times pi times 2h all squared is going to be 4h squared over 25 times h. So we've got 4 pi h squared times h is h cubed over 3 times 25, which is 75. Okay, so we're left with what we asked to show, that v equals 4 pi h cubed over 75. So there's part 1 or part A of this question. Okay, about related rates of change kind of thing. It's actually setting us up for the second part of the question, actually. So there's part A. Now for part B, let's just make sure that's correct. 4 pi h cubed over 75, that's right. Now for part B, it says given that the water flows into the container at a constant rate of 2 pi centimeters cubed per second, find in centimeters per second the rate at which h is changing exactly 1.5 minutes after the water starts. Now they've bolded, put this in bold type. That should flag up something for you. If we go back to here, we see that, you know, everything else is given in terms of seconds. Okay, so here we're told that the rate is per second, and here they've got minutes. So we've got to be careful about the units here. That's the first thing you have to take note of. So now, in these type of questions, these related rates of change questions, there's always something given. There's always something given. Okay, in this case, what's given is the rate of volume flow into the container. So what's given to us in the question is dV dt, which is 2 pi centimeters cubed per second. And there's always something which we have to find. What do we have to find? In centimeters squared per second, the rate at which h is changing. So we have to find dH dt. Right? So it's always like this. Every question is like this. So we take what we have to find, which is dH dt, and we use a chain rule. So we use what's given, which is dV dt, and then we ask ourselves, what do we have to multiply this by such that we end up with dH dt? So of course we need a dH on top, and we need to get rid of the dV. The dt is there already, so we have to find dH dV. Okay, how can I find dH dV? How can I relate the volume and the height? Well, with this. Okay, so I can find dV dH from this, and then the reciprocal of that will be dH dV. So this is like, let's just rewrite it in a more friendly way. 4 over 75 times pi h cubed. That's kind of a bit more friendly for differentiation. So I'm going to differentiate this expression with respect to h. That will give me dV dH. So 3 times 4 over 75 times pi times h squared. Now 3 goes into 75, 25 times. So I can cancel this and put 25. So I can say dV dH is equal to 4 over 25 pi h squared, which means that dH dV is equal to 25 over 4 pi h squared. So I can say now that dH dt is equal to dV dt, which was given as 2 pi times 25 over 4 pi h squared. Okay, so the 2 cancels with the 4, giving you 2 here. The pi cancels with the pi. So we're left with dV dt, dH dt, sorry. dH dt is equal to 25 over 2h squared. Now, it says we got to find the rate at which h is changing exactly 1.5 minutes after water starts flowing into the container. All right, so now we have dH dt and we have it in terms of h. We want to find it in terms of t. Okay, so we've got to think a bit about this one now. How do we find the height of the container, the height of water in the container, okay, 1.5 minutes after it starts flowing into the container? Okay, so we want to find that. That's what we need to find. Okay, so now what we got to think about is the fact that they told us that the water flows into the container at a constant rate. at a constant rate of 2 pi centimeters cubed per second. Constant. Okay. So 1.5 minutes after water starts flowing. So we can say that, dV dt is 2 pi centimeters cubed per second. Okay. 2 pi centimeters cubed per second. And the time for which it's flowing is 1.5 minutes, which is the same as 1.5 times 60, which is 90 seconds. Okay, so we have to do it in seconds, of course, because it's per second. So therefore, after 90 seconds, the volume of the water is going to be 2 pi times 90, because every second, 2 pi centimeters cubed flows into the container. So after 90 seconds, it will be 2 pi times 90. It's a constant flow, it says. That gives us 180 pi centimeters cubed, after 90 seconds. So that's the volume of the container. So we can work out the height of the container because we know from this formula here, we know that we can find the height of the container when the volume is 180 pi. So we have 180 pi is equal to 4 pi h cubed over 75. Well, the pi's cancel out. 180 divided by 4, well, 180 divided by 2 is 90, divided by another 2 is going to be 45. So you've got 45 here. So you're left with 45 times 75 equals h cubed. So h cubed is equal to the cube root of 45 times 75. Let's see what that gives us. H is equal to, the cube root of that. Okay, so we can work that out. So we have the cube root of 45 times 75. That gives us 15. Okay, so it gives us an exact value. Good. That's 15 centimeters. So we can now work out what we need. We know that at t equals 90 seconds, the h dt is going to be 25 over 2 times 15 squared. Okay, 2, because the height will be 15 at that time. So it's going to be 25 over 2 times 15 squared. 2 times 15 squared. That gives us 1 over 18. I'll leave it as 1 over 18. This is centimeters per second. Okay, that's the h dt. So the h dt at the time we want is 1 over 18 centimeters per second. And I think that's what we had to find. So it's slightly more tricky than most of the questions that you see of this type, because we found the h dt in terms of h, and they told us to find it at a particular time. So we had to find the height of the water in the container at that same time. And we had to put that in here. And we did that by, just finding the time, the volume at that particular time, and then working out the height of the water at that time. And we got the answer. So there's the answer to this question number 5 from the October 2024 Pure Mathematics P4 paper, all about related rates of change. Other questions from this paper can be found in the playlist that will appear in the top right of the screen at the end of this video. Other questions from the topic of related rates of change from P4, you can find it over here. And in this area, you'll find a playlist dealing with differentiation from P4 in general. You can subscribe to the channel by clicking on the link at the top. Thank you for watching and see you soon.